Hello everyone, thank you for coming in such a great number. Bonjour. We're a little late, so I'll try to keep it, below 7 p.m. so you can go and party with the rest of the attendees. My name is Ana Baotić. I'll be talking about keystores and certificates today. I come from a small country called Croatia. You see the arrow pointing from France to Croatia, so if you want to see our beautiful coast, be sure to come during the seaside when it's truly beautiful. We also have the location for Game of Thrones, if that's your kind of thing. Don't come during the summer because you won't be able to move for the city. It's supposedly, a big deal. I work at a company called Asseco. We do fintech. We do mobile solutions for, core banking and mobile applications. And today, like I said, we will be covering a security topic that is fairly simple, but it's kind of, if you get it wrong, you get it really, really, really wrong. And of course, I'll be sharing my own personal experience because embarrassing topics is what conferences are usually great for. So let's start from the beginning. A certificate is a document. Simple as that. We all know that. But what does that mean? A document that proves ownership of a key. What key? What ownership? Whose ownership? So, it has a structure. That's cool. But what does that structure actually contain? And finally, where is it used? You use it every day. You see it every day. Your browser, your mobile phone communicates using it every day. And we will see just how wrong things can go if there's something, kind of missed on this topic. So, let's start from the beginning. Each certificate contains an identity, which means if you're Google, and you're not, you need to prove that you are actually Google. Your name, your address, your phone number, the person who is responsible, like a representative or something else, and basically provide that info. Second part is the public key. Great, okay, the key and it's public, but how do we get it? Where does it come from? Let's go just a little bit down the rabbit hole into cryptography. So asymmetric cryptography is basically any kind of system that uses key pairs. In our particular situation, we have asymmetric cryptography, which means that keys are not the same. We have a public key and a private key, and they are not the same. How do we calculate them? Well, we use a really big random number, huge number. We have some kind of algorithm, some kind of function, and we calculate two keys, which need to be calculated in a feasible manner, which means that you have to get them in a reasonable amount of time. So if you want to calculate two keys, you probably don't have half an hour, day, 2 days for them to be calculated. Then, on the other side, if you want to reverse the process, anybody who tries to kind of detect the private key based on a public key, they need to be able to spend like a millennia doing it, otherwise the whole system is kind of insecure. So, as I said, we have a private key, which belongs obviously to the owner and must be known exclusively to the owner. In terms of Android applications, the owner is you or your company or your team, and you need to keep it safe. Public key obviously goes out into the wild and anybody can use it, and we'll see how. Now, the private key is typically used to decrypt messages, and the public one to encrypt them, which means if you have a communication channel, I, as an owner of the private key, will wait for somebody to send me an encrypted message using the private key. And then I can use my private key to decrypt it. The keys work kind of inversely, which means you can use either one to perform one action and the other one to kind of undo it. And finally, when we get to signatures, in terms of Android applications, we'll see that the private key is used to calculate the signature, while the public key is used to kind of confirm it, whether or not it's okay. And signatures, again, are used for three things in our case, in any case altogether. First is authentication, which means that a message was created by somebody you know. Is it Google? Is it you as a developer? Doesn't matter. It proves basically the authenticity. Second one is very important, and it means that basically non-repudiation is that you cannot say, okay, I did not send that message. You either sent the message and there was something wrong with it, or your key was stolen and somebody sent the message for you. So it uniquely shows that you sent the message or your key was stolen, which is useful to know. And finally, integrity, in terms of the message that you send, does not get altered somewhere in the communication channel. If your application is hijacked, decompiled, changed, signed with a different key, its signature will not be the same. This is how we prove integrity. Okay, so in terms of calculating a signature, we don't use the original message and just determine what's the signature on that. We usually calculate a hash using some kind of digest function, and then we transform that into a signature. Why don't we use the original text or the content? Well, lengths differ, and we need some kind of standardization that will transform any kind of content into an object that can be then used to get the same result. So, just to keep this in mind, senders encrypt with their private key, and recipients decrypt with their public key. This is simple. Now let's get back to our certificate. So we know that we need to set the identity, we need the public key from our key pair, and we need something that's basically a signature by somebody who we trust. The certificate authority is something that is an entity that we will definitely trust, and let's go into details about that. So a certificate authority is any kind of entity that issues digital certificates. Now this kind of seems like we're describing one item by the other, but this part is this is basically the root on which the whole system lies. So a certificate authority is any kind of entity that we chose through different programs and certification procedures that we will trust. The first thing that any certificate authority does is to produce a certificate, their own, because that will be used onward in the whole process. So again, we kind of have a loop or recursive here, where we have a person that we trust or an entity that we trust, and then they provide content that, in terms, other will trust. Now, to become a certificate authority, you cannot just say, hey, I want to produce my own certificates, please trust me. There are rigorous programs in which you have to enroll and different kind of steps you need to conform to for you to be acknowledged as an authority. And once you are, your root certificate, your original certificate, will be included in a security patch for your browser or your operational system. So don't skip on those. It's very important that you apply them as soon as you get them. I know that generally Android users kind of aren't, oh good, a new update, let's immediately, apply it. They kind of wait, and with 2 billion devices, that's very prominent. But it's important that you advise your users in any way possible to keep up with any kind of update that exists. Now, just a few companies that are basically referenced to get certificates from, we have Komodo, IdenTrust, Symantec, and they are commercial entities, which basically means that you have to pay a lot of money, or less money in terms of what you think a lot of money is, to get a certificate for your company. Now, you can always use Let's Encrypt, which is a solution that was they came just a few years ago, and they will allow you to get the certificate without paying a lot of money, which is great. So, let's take a look at Google, since we've been referencing it today. If you open the certificate for Google, just so you open a Google in any kind of browser, and you click on the little secure part in the left part of the browser, and you can basically take a look at their certificate. So once you open that, you can see that there's obviously 3 chained certificates, and the leaf one, the lowest one, belongs to the company. Now you can see here in the description, or you probably can't due to the light and everything. The issuer name here is Google Internet Authority G2. So we know that this particular certificate was issued by an entity called Google Internet Authority G2. Okay, great, but who are they? So if we take one hop upward, we can see that certificate. And then we can take a look at the data here. And now the issuer for that particular certificate is GeoTrust Incorporated. Now I already mentioned that GeoTrust is a certificate authority. And if we hop back to the root, we can see that that particular certificate is a root certificate, which means GeoTrust created it for themselves and they signed it themselves. So it's kind of, okay, we elected to trust you and this is how you basically start the whole procedure. In terms of chains, you always have a root certificate that is signed by the entity themselves. You also have the intermediate certificate, which is something in between. And finally, you have the kind of identity certificate, which is produced as a third step. Now, this is important for several reasons. All of them we'll cover a bit later. I just want to cover one more thing in terms of certificates, and that's how they're represented on the web. Now, you have two options when you open a website. HTTP is probably not either of them, because we're talking about security and we're talking about HTTPS. You'll either see a secure mark with a little locket, or you'll see a name in the bar. Now the difference is how many hoops the entity will have to jump through in order to get their certificate. So if it's just a locket, it's domain verified, which means they're just proving that a particular domain belongs to an entity. If you see a company name, like Google Inc., etc., that means that they have taken extra precautions and extra steps to prove that who they say they are is actually who they are. So it's a lot more difficult to get that particular name. Now, the main problem with certificates is subversion. In layman terms, it means that if you have some kind of a root system, like a tree, you have the root certificate, intermediate certificates, and the entity certificates. When one of them becomes infected or corrupted, everything that they signed, and in terms their children signed, is kind of invalid. So you need to remove them, you need to create new ones, sign new ones with the first, kind of node that you trusted, and recreate the whole procedure. So, key theft is a big issue, and you should be very, very aware of that. The whole scheme of this certificate signing is flawed, and there were problems on a bigger scale. I'm not talking about you losing some of your data, I'm talking about Microsoft trying to probe a user that was able to get, let's say, root@microsoft.com email address, because the certificate authority thought, okay, only users with root, SSL admin, and other on a particular domain have the right to, administer the domain. But that's not always true. So the system has a flaw because it's run by people, as most systems do have flaws. Another thing to keep in mind, big companies tend to use hardware secure models, so HSMs, for key storage. So we're not talking about a Git repository or a USB stick or, locally somewhere hidden in your office. We're talking about devices, mechanical devices, so susceptible to movement, voltage changes, tremors, somebody picks it up and throws it, or just kind of opens the window and changes the temperature. And if you want to do anything with that kind of device, you need 2 or 3 or 4 people with hardware tokens that you put into the device in order for you to do anything with it. It's so sensitive that any kind of modification or tampering will erase everything on it. So Git repository, fine, storage, backup, everything is fine, but if it's that important, and it is in terms of web, you need a better solution for that. Of course, those kind of machines are kept offline, and if you need to sign something with a key that's present on it, you briefly, gather those 5 or 10 people to unlock it. You sign what you need to sign and take it back offline. So it's a big deal. Now, Android doesn't play nice when something's wrong with the certificate chain. More notably, if you have a self-signed certificate or something that was issued by an untrusted certificate authority, for instance, I might say, okay, I don't want to pay and I don't like let's encrypt. I'm going to be my own certificate authority and I'm going to create a certificate. And I'm going to place it on my website and my application will communicate with it. Android will say, no, Anna, it will not. I will not communicate with something that I don't trust. And it won't trust it because me, as a certificate authority, I don't have my root certificate on the device. Now, if you ever pin certificates in your mobile application, you might have, a few years ago, taken any kind of root certificate of a self-signed variety and installed it directly on your Android phone. And it would work up until, I think, Android M or N, I'm not completely sure. Android said at that point in time, okay, I'm no longer trusting any user-installed certificate, but here is a cool feature called the network security module config, where you can list all the certificates that you trust, their public keys, how long you will trust them, lots of different configuration items. And then you could state in that particular config, okay, I will trust user-installed certificates. Okay, so that was one solution if you were really lazy. And the other one was obviously certificate pinning, where you would take a certificate, calculate the key, and just kind of push it in your app and use it onward, which is a good solution until you deal with a human client, which tends to be interesting in terms of, let's say they update something on their servers, and of course you as a vendor, they don't feel compelled to notify you of the change. So on Monday morning at 5 a.m. you get a call, an angry call of course, there are no other calls than angry, saying, everything is broken, my application is not working, what did you do, what did you break, fix it immediately. And okay, you're a diligent developer, you check the statistics, you go on Fabric, and you see that, no, nothing's happening. You get exceptions or you don't get exceptions, or you just try to log in the app and it's not working. What happened? The client decided to update something or change their certificate on their website, and your application is no longer trusting them, which is expected behavior. But the implication of that change will leave 1, 10, 100,000, maybe more users very, very angry. So if you're doing something like certificate pinning, be sure that your client is very well aware of the problems any kind of change it can cause. Now, signing Android applications. In order for any application to be deployable on an Android device, it needs to be signed by, digitally signed by a certificate. And when you deploy any kind of debug application on your device, it's automatically installed. And that's because you are probably, by default, using your debug Keystore. Now, can anybody here tell me what's the password for your Android debug Keystore? Android. Okay, so that's not super, secure, right? We all know the password. The Keystores differ from all of us because it's local to your machine and it's created at a point in time. It's valid for 1 year. But if you're working in a team and you try to, deploy an application directly in a debug mode, you won't be able to update the app between 2 or 3 or 4 developers. That's because our signatures won't be the same. Now, if we need to work as a team, and most of us do, what's typically done is that you will create a Keystore and a key for your application, even in a debug mode. Because, like I said, deploying, regardless if you're using a CI or something else, maybe you're just working in a small team and don't have the whole thing set up, you probably want to create a Keystore for all of your builds. The same or different, we'll get to that later. And you'll want to sign your application, not with the debug Keystore. So this is something you've all seen. I predict that at least once you all deployed something into production or you created a production build. Now, I won't go into details. This is the dialog you get when you need to create a new Keystore in your application. Just a quick overview. You select the path on top. You define the alias for your key. You set the validity, which needs to be at least 25 years, because Google is very optimistic on how long users will use your application. And then below that, you have the certificate info, where you place the identity of the person or the company that created it. Now, if you have the Keystore already, you'll just get a really, small dialog saying which one do you want to use for signing your application. If you don't like, this cool, dialog thing through Android Studio, you can always go old school and use kind of, command line tools to sign and verify your application. We won't go into detail. You've used Keystore at least once when you had to add the application signature to Google Play Developer Console for maps or something else when you wanted to limit the traffic. The zip line will do some magic in terms of aligning your APK to use less RAM onward. And the RSigner is used to sign the APK that you have. Now, we have a big decision to make. Humans tend to make mistakes, and Lord knows that my company and the previous company has made a lot. We need to make a big decision, and that is who is going to be responsible for our signing key. Now, the way it was before, you created an application, you signed it, you deployed the APK on Google Play, and everything was fine. There's nothing wrong with this system. It's worked for years. Our expectation is that you will be able, with each update you make, to push the new update on Google Play and your users will get it. Seems legit enough. Now, prerequisites for that is that your key is safe and that it's accessible. Again, so simple, so basic, what could possibly go wrong? Well, in reality, people drink and spill coffee, and they kind of switch companies at some point in time. You probably won't be, working at the same company throughout your whole career. And confession time, of course. So let's start with a small story. So there was a developer named John at a company far, far away who created an application, he signed it, he pushed it on Google Play, everything was perfect. At some point in time, he spilled coffee on his Mac and had to get a new one, and later on he switched companies. He did not get fired because he drank and spilled coffee, it was kind of a natural flow. So 6 months, 1 year later on, the client came and said, your application is amazing, let's just add this small feature to the application. So a new developer came, they added some changes, they created the build, they sent the debug build or the test or UAT build to the client, everything was fine. And then came the day when they needed to push it to Google Play. What would you argue? Now, our developer came and said, okay, I cannot sign this application, it's not working, there is no Keystore. Of course, the first question, what do you mean, no Keystore? So it's probably in the Git repository, although you kind of logically think it has to be there. So you check again, and then there's no Keystore there. So you go through the Git log entries and try to find any reference to a Keystore, alias, signing, application is out, yay, let's go drink or something else. And you see the entry where obviously the data in the build Gradle was entered, but there is no Keystore. Again, was it deleted? You simply don't know. And then you take a closer look at the build Gradle file, and you see that the location of the Keystore is really nowhere in the project. By nowhere in the project, really nowhere in the project. The Keystore never ended up on that Git repository. You have the password, which is bad. You have the alias, and you have the other password, which is also bad, but the Keystore is not there. Now, seeing that it's almost 7 p.m. and you need to go party, I will tell you that the story has a happy ending. The Mac that was spilled with coffee was actually in the company in some storage, and we managed to contact the developer, get their password for the Mac, and basically where it said it was on that computer. But there are bigger companies, more, let's say, smarter companies with very, people that know what they're doing, who haven't been this lucky. Which means when you're using a popular application and suddenly they say, oh, that's cool, but let's say, we have another version of the application, so package name .new. Let's install that one and you continue using that one. That's not because they're bored or they want to annoy you with their change, it's because something happened to the Keystore and they can no longer update it. So have some sympathy. I've actually talked to a few people and they've shared similar experiences with more or less luck in the whole procedure, but losing a Keystore is a really, really bad thing. Next to the fact that somebody gets your Keystore and the private key, because then they can produce an update of your app that will have the same signature, and they can create a phishing campaign that will allow your users to be exposed to some kind of, identity theft or privacy leaking or something else. So keep it safe, but know where it is. That's kind of the baseline. So Google obviously has seen instances like this, and they said, okay, developers, we really love you. Let us throw you a lifeline. Let us help you. So they introduced something about a year or a year and a half, maybe even more ago, and they said, okay, please upload your signing keys to us. We will keep them safe, and you can use something that's called an upload key. So if your upload key kind of gets stolen, corrupted, or anything else, you can always kind of pull our shirt and say, oops, I did a bad thing, I no longer have my key, or somebody has my key and they shouldn't. Can you please just revoke it and issue a new one for me? So they came to the rescue. So if you don't want to be responsible for your own key, then you have a good solution where somebody's basically taking the fall for you. Now, if you have an existing application on Google Play, you need to know that this decision to switch to Google Play signing is permanent, which means you cannot say in 2 weeks' time, oh, I changed my mind, I will publish it myself. You cannot go back. Now, for new applications, the procedure is quite simple. You have 4 steps. We will not go into them because they're very well described and defined. Basically, you create an upload key and you sign your application. You opt in for the program, you upload the signed APK, and that's just it. For existing applications, there are some additional things to do. First of all, you need to opt in for the program, which means you're acknowledging that you cannot go back. Again, that's an important decision. You create an upload key. You update your local key stores because you will be signing it with the upload key, and you just continue like you did before. Like I said, Google to the rescue. If your key gets compromised or lost or stolen, you can always tell them, please revoke that particular key and issue a new one, which is great. Okay, so first decision probably made for most of you. And the second one is, what if you have multiple applications or modules or flavors or anything else? Now, this is usually driven by the business process, so you know best. If you have an application that needs to share data with another application, so anything that revolves around communication, you might use the same key store and the same key because you want those applications to communicate in the same process. If you have modules, then you can choose to update a certain module and publish that and not the whole application. And of course, like I said, for the debug build, don't use your debug key store, create a modified key store or anything else and use that, and make sure that your whole team uses the same thing. In terms of pros and cons, well, like I said, modularity, permission-based sharing, and of course that it's updatable if you have a big team working on the same feature. And the con is obviously a single point of failure. So if you have one key store for everything, if something happens to it, then you're kind of doomed. And to illustrate Android security, or any security concept whatsoever, it is as secure as how much access you have to it. So if you have lots of team members going through the team, if they all have access to your key stores and your keys, then it's a problem, not because we inherently think that something will be, bad and they will steal data from us, but because it can wind up on an USB stick or somewhere else and get out of the company, and then you're exposed to something you shouldn't be. And that's it. Limit the access and be sure that you actually have access, because if that bridge burns, then you'll have the most safe application in the world. Not even you will be able to touch it. Now, in terms of data and applications, if you need to do some kind of cryptic stuff in your application, you need to store some data in it, then you need the most safe solution. And I'm not talking about shared references with private mode on or something like that. You need the safest possible solution to keep your data, to store it locally, and Android Keystore system is something that you should be considering. So they boast, and they boast with pride, that it safeguards your cryptographic keys from extraction. And they literally do that. Whatever you use and keep in your application and store, nobody will be able to extract or get or modify. Now, in terms of keeping private and sensitive data in the application, nothing says it better than a UML diagram. So I created one specifically for this purpose, and it will help you decide whether or not you should keep any kind of important data in the app. So if it's important, don't keep it. It can be reverse engineered, it can be stolen, it can be, kind of sniffed out. And if it's not important, then like code, best practices, and the rest, keep it out of the application. Remove it. Like you would delete a comment or something else, don't keep it if it's not meant to be there. So, and if you still say, oh no, but I really need to keep some data in the application, then you should opt in for the solution that will help it be truly safe. Now, as I said, Android provides several things that helps things really, really safe. And it's the safest when that material is bound to some kind of hardware element on the device. Not kept in memory, not software related and managed, but physically kept in, let's say, a trusted element or a security element. It's basically like a mini part of the device where you have your own CPU, you have your own storage, and you cannot tamper with it, you cannot modify it, change it, you cannot clone it to another device because it's bound to that particular device. So that's a good way to go if you can. And what's typical as we kind of try to keep our code clean and separation of concerns, you don't keep your business logic in your views, and you try to adhere to best practices, you should, if you're using some kind of cryptography or storing keys or anything else, you should really specify what they are there for. So don't use one key for everything, for signing, for verifying, for decrypting and encrypting. Say what a particular key is for. So separation of concerns, if one key gets, I don't know, anything, then you'll be able to just switch one thing and the rest will be safe. In terms of the Keystore provider, once you define something in it, it cannot be changed, which kind of allows us to be extra, confident that nobody will be able to tamper with the data. They can either delete it or insert a new one, but they cannot modify something that's been already added. In terms of cryptography, you have lots of options in terms of choosing what kind of algorithm you want to use, whether it's elliptic curve or something else. The validity, how long something will be, valid from the moment it's unlocked, etc. And you can also say that once unlocked, it can be valid for 5, 10, 15 minutes, depending on the use that you will be having in your app. And that's a good way to do stuff, because, again, separation of concerns. Now, you have two utility methods at your disposal, which were unfortunately added only in API 23, or else the key info class was added at API 23, which allows you to check two things. First of all, whether any kind of key is in a secure place, in hardware security place, which means extra security. And also this really, really long method that somebody was saying today, I think in the keynote, that they're bad at naming things. This is really descriptive and long, so if I haven't lost you, It basically checks whether something is enforced by, user unlocking and enforced by security hardware. Great. Okay, now you have also two choices here. You can go for the Android Keystore provider, or you can opt in for the keychain. Now the keychain was introduced in API 14 and the provider in 18. And obviously this translates to a huge number of the 2 billion devices that we have. So again, your business need will probably dictate which you will be using. But just to sum it up, if you use the keychain, you have the system-wide credentials and you get the standard UI dialog which lets you choose which you will be using. And again, the Keystore provider, which allows you to create a specific key for a purpose for your app. So modularity, you can kind of home it in on a specific purpose, and no interaction. You communicate by code, so there's no system dialog or anything. A little bit of code before you go out having fun and partying. So if you want to generate a key pair, you need basically 3 calls. One is to get an instance. In this particular case, the elliptic curve algorithm will be used. You can choose whichever you want. There are several of them available. And the instance is obviously Android Keystore. Now, you initialize it with all of those little kind of tweaks that you can. For instance, it's for signing and verifying, not for all 4 purposes. And you know that you can use SCA 256 or 512. So you can specify which algorithms and types it will work with. And at the end, you just generate a key pair. So simple code, short code, it doesn't require much knowledge or practice to create a key pair. If you want to list entries, it's even simpler. So you get the same instance, you load everything that's in it, and then you can just iterate through all the aliases inside. Now, if you want to sign data, you might create a signature. In this case, it's SCA 256 with elliptic curve algorithm. Then you initiate the sign with a key, a private key from your pair. And finally, you just update the data and get the signature. Again, simple, short, there's really not much to discuss here. And if you want to verify a signature, you just, again, get the instance, you initiate the verify, and at the end, just ask whether or not the signature is verified. So true, false at the end. Another thing to keep in mind is the key attestation process. So basically, you're trying to verify for a specific key whether or not it's stored in the device's hardware part, which is great, but only a small number of devices from API 24 have the possibility to have this. So if I'm not mistaken, a few weeks ago, the last statistic on Google Play was that 1.1% of all devices was on the newest API. So if we're talking 2 billion devices and the latest Android version, 1.1. After almost a year after it was released, that's depressing. And not because people don't want to update, because most of them won't be able to. So this brings us to the state of Android, which is fragmentation. There are lots of images with those cute little, dimensions and colors, and they're really colorful, and it's great. You have like 1,000 devices or anything else. I think it's closer to this, because this will make or break your application and the security within it. So if you have something from API 24 or 23, you cannot target all the users. And if your application needs to be, at the top level of security, you will have to make a compromise between the number of your users and the security level that you'll be able to produce. Now, Android P is coming, and I'm really rooting for it to be Pancake. If you have other suggestions, feel free to kind of volunteer. They are bringing some cool features in. One of them is key rotation. So if you decided that you will be taking care of your own keys and not allow Google Play signing to take over, Then this will allow you, for each member of your team, to have a different key, and those keys will be rotatable, which means that you will be able to sign the application, and if somebody leaves, it's easier to kind of snip that in the butt. And also the Strongbox, which is a hardware secure module. Again, it won't be available for everybody, and not all devices will have it, but it's a cool improvement. Now, before we end this session, I would just like to point you to a few things. One of them is the transparency report from Google, where they have a great glossary of all security items and kind of the overview of the state of security on Android. Also, if you are your own entity and you have your own product and your own website, go to Qualys SSL Labs and check the security of your website. You will get the grade from A+ to, I don't know, F or T if it's really, really, really bad. And one more thing, there's a lot of information on it, but also if you have a huge user base, based on the security and the algorithms on your domain, you will be able to tell which API versions of Android or browsers you'll be able to communicate it. Now, we've all moved to higher API levels on Android, but sometimes it's a factor in the decision what you will be doing. And finally, it's on you to decide what's the balance between the security that you want to provide and the user base that you're targeting. So it's a huge responsibility, and it's solely in your hands. Do the best you can. There are several tools. Again, at today's keynote, they said, we don't have best practices for you. We can kind of nudge you in the proper direction for where we think you should go if you're starting out. But nobody knows your business needs better than you. So kind of, common sense and best practices if possible. And I would like to thank you for your attention today. And I hope you have a great time at the party tonight and tomorrow at the conference. Thank you. So you can grab me at the hallway or tonight at the party or whatever, because session is over. Run.